Hello, welcome to DevNexus. In this video, I'm going to discuss on the problem 3 sum. Here, we are given an integer array nums and we need to return the triplets such that the sum of the elements nums I, nums j and nums k will be equal to 0 and such that indexes I should not be equal to j and I not equal to k and j not equal to k, and the solution set must not contain duplicate triplets. So if we see the array nums, this one here, -1 plus -1 plus 2 will be 0, then -1 plus 1 will be 0. So we are able to find these two triplets which values equal to 0. Nums 0 plus nums 1 plus nums 2 will be 0, and if we see this particular first option and the second option, the values in these are same, and here we are given solution set must not contain duplicate triplets, so we are going to take one from these two values and our answer will be these two, because other one is -1 plus 2 plus -1. So we are able to get these two triplets. In this particular problem there is no triplet with sum equal to 0, and here there is one triplet 0 plus 0 plus 0, and that we are appending into the returned array. So in this particular problem I'm going to explain the logic. Let's me take the brush. It's -1 0 comma 1 comma 2 comma -4 and -1. The easiest way to solve this problem is by using brute force. In brute force we are going to take two positions, this one and this one. These I am fixing and I'm going to traverse the remaining array. So my triplets will be -1 and 0, which is fixed, and 1, -1 and 0 are fixed, 2, -4 and -1. These are my triplets. These and I'm going to check if it equals to 0 or not. First one is equal to 0 and this one is not equal to 0. Likewise I'm going to check for every triplet if the sum equal to 0, and if it is there then I'm going to append it into the array. And if I see the array which equal to 0, I need to add it into the set triplet so that there should not be no duplicates, that we can handle it. Now understand the time complexity of this problem. These are the two pairs. We have to take two pairs from this particular array for the fixing part. So for every pair we have to traverse the array to n times, and in this particular array our pairs will be n square, because our positions like 0 comma 1 is our first position, then our second position will be 0 comma 2, then 0 comma 3, which are our fixed positions. So in that way our time complexity comes to be n cube, which is very high. So this brute force way is so much high, and there is better way to solve this problem. I'm going to solve this problem with that particular way. So I'm going to take the brush, -1 0 comma 1 comma -2, this is +2, and -1 and -4. So let's take the values are fine. Okay, the values are okay. Now firstly I'm going to sort this particular array. Now our array will be -4, -1, -1, 0 and 1 comma 2. So our array is behaving like this, and for this our time complexity will be n log n. So now we have sorted it. Now I'm going to use two pointers approach. With this I'm going to fix my ith index. This is the outer index, or I can say that this is my outer index. This index I'm going to fix it, and I'm going to traverse the two pointers in the remaining part of the array, left and the right. And then I'm going to traverse by checking the triplets. Like first our triplet will be -4 comma -1 and comma 2, which is equal to -3. So -3 is less than 0. So in that case I'm going to increment my left pointer so that my value sum will be closer to 0 in the next case. So now my case will be -4, which is fixed, and again I'm going to get -1 and 2. So it is will give me -3, which is not equal to 0. Now again I'm going to increment my left pointer. Now it will be -4 and 0 and 2, which will give me -2, which is again less than 0. Then I am going to increment my left pointer again. So my values will be -4, 0 and 1. It will give me -3, which is again less than 0. I am going to increment my left pointer, but now my left pointer will be equal to right pointer in this particular case. So I am going to move out of the loop. So basically our first iteration is over in this way. Now in the second time I'm going to increment my I pointer to this position, and then I'm going to traverse this two pointers case in from this to this position. In that way I can check all my triplets which sum equal to 0. But one thing I need to understand, that there is possibility that uh, my like my -1 and -1, these two are same values. So I need to check the conditions for the duplicates and identify those scenarios that I'm going to explain in the problem. um, right now our complexity will be, if I check for, if I'm going to check for every index this two pointer approach, my one time if I go with two pointer approach will be n, and for every index my two pointer approach will cost me n square time, and already we are having n log n plus n square, which will be give me n square. So n square will be my time complexity of this problem. Now I'm going to explain the solution in the code and write the code which will give you more understanding of this code. So first of all, nums dot sort, it will sort my array. Now I'm going to traverse the array, and note, if I'm going to check my triplet, it should be the third last element I need to traverse, so that my other two values left and right should be second last and the last value. So I can't be traverse to the second last element the outer variable. So then in that case it will go to the out of range scenario. So that's I need to understand right like this. This is my outer index. Now I am going to make my left index and my right index. Left index is I plus 1 and right index will be length of nums minus 1. And now I'm going to check my while left pointer should be right pointer, less than right pointer, and I'm going to add the sums of the particular case, nums I plus um, nums L plus nums R. Now I'm going to check if s equal to 0. If it is if it is the case, then I'm going to append this particular value in this new array by making this as a array and appending that array to array. I mean, this is new array of these three values, and that I'm going to append it. Note, now I have to uh, understand that I should handle the duplicate case. So for that, what should I do is, first of all, if we have find the like triplet, I'm going to explain this very in simple terms, like x, y, z, w and v. So in this scenario, if I see, this is my outer, this is my left, and this is my right. So if x plus z plus v gives me 0, so I am going to increment my this pointer and this pointer. I mean, I'm going to increment my left pointer. Let us suppose this is no, I mean, this is a, and our right pointer was there. Now this is a, x plus z plus a equal to 0. So now I'm going to increment my left pointer and decrement my right pointer. So our values will be w and v. Then I'm going to check for these two scenarios, because every time when we have find the solution, that is the only solution. Now we have to increment or increment our increment or decrement the pointers from both the sides as we have find the solution. So that the case we have to check. So L plus 1 and right minus 1, because we have find the solution, and now we have to increment the index from the both sides, because we are even have no kind of no situation of any duplicate triplets we need. So I am doing like this, and now I'm going to check the case that my previous value should not, I mean, if my z value is equal to w, then there is no need of uh, adding this triplet again and again. So I'm going to increment the w point left pointer. For that, I'm going to write this particular case, uh, um, nums L not equal to, sorry, nums L equal to nums L minus 1. I mean, when we have increment this particular pointer, now in that case, whatever we have added, that should not be equal to our new value. So that's why I'm returning it to minus 1. If it is that case, then I'm going to increment my left pointer and check if my left should be less than r. That's the only thing we have to check. And the same thing I'm going to do with the right pointer case. Here I'm going to check if nums are minus plus 1, sorry, here will be plus 1, and I'm going to decrement my pointer like this. So this is the case to handle for the duplicates. Now I'm going to check if sum is less than 0, then I need to just add my left pointer so that our value will be closer to 0. And if my sum is greater than 0, then else, or you can say, then I have to decrement my right pointer so that my value decreases and my sum will be closer to 0. and this is it. This is uh, like all, and in the end we have to return the L1. And note that there is one case, like there is we have handled the duplicates for left pointer and right pointer. There is scenario for outer loop also, that x, there is possibility that x can also repeat it. So that case also we have to handle, and that we can handle it by writing if I greater than 0 and nums of I equal to nums of I minus 1, then we have to continue it. So meaning when our previous value is equal to the, I mean, if the index is 1 or more than 1, more than 0, then in that case our previous index if is equal to the previous value, then we have to continue it so that our duplicate will not get stored in our L1 array. And now we can run it and to check if it runs fine. Yes, it runs fine. So yeah, we can say it's fine, so it's completed. So I think it was a great solution, and um, uh, this is it, and I'm going to delete it. So it was a great work, this solution, and you can guys solve it yourself or check the solution again. uh, and this is it for the video. I think if you have more doubts or anything else, you can write in the comments. I can write whatever you want. And please guys, if you need any help, you can just comment on the comments. And this is it. So I'm glad that we get solved this particular solution. So thank you guys for this problem.